well that the backbone of the network is quite well managed, and no independent or almost non-independent losses will occur, and so the main source of error will take place at the end of the network, which is essentially bursty. In these under these circumstances, it is better, it is more efficient to devote all the protection to create column-wise generated packets, and this situation allows for creating matrices with a greater number of columns and fewer rows, which is more convenient. So these simulations have been performed using these channel models, Ray model, which I have already mentioned, and the liberated model, which is very widely used, in which the burst errors are simulated in such a way that they can vary, their length and they can vary. So the overall distortion values that has been normalized with respect to a reference value that is the best performance of the standard codes. And we have done that so that we can more easily see the difference between the different approaches. This is the same scenario basically, but we have used different functions to simulate the different importance of packets in the block. So first the uniform, second linear, quadratic, and cubic. What we can see here, so first this is the relative distortions in the vertical axis, and in the horizontal one we express the number of packets that are available in the detection block. We can see that the results obtained with our extension are better than those obtained with the standard codes if two main conditions are met, which are that the combinations that we create, the configurations, can simultaneously cope with burst errors, and that we can provide enough unequal protection to video packets. So regarding their importance, their relative importance, that is done by creating matrices so with sufficiently great number of columns, and by using the sufficient number of matrices so that different sets of data packets can be better arranged. So, and now we will go to the optimization technique that we have developed. So, in the previous extension, the selection of the most suitable configuration is carried out for each different effect block, which means that we will have full adaptation to the characteristics of the string, which is very good. But we have a problem, which is that the number of configurations that this extension can allows, it can be potentially very high. And so we cannot use exhaustive search or methods of the kind to look for the optimal configuration. So we here introduce a new optimization procedure that has two main complementary objectives. The first one is to reduce the solution space of so the number of feasible solutions in this solution space. And second, to use an heuristic, so a procedure to guide the search of these good configurations. First, we just reduce the solution